Hello everyone, I am Santosh MV, Assistant Professor from Department of Chemistry from VTU Regional Center, Mysore. So I am here today to discuss about the topics included in Module 1 under Applied Chemistry for Mechanical Stream. In that, today we need to discuss about the power alcohol. What do you mean by this power alcohol? Power alcohol. This word is very familiar for you people. You know what do you mean by power and you know what do you mean by alcohol also. So the chemical fuels which we use to run the motor vehicles or automobiles, for example petrol or diesel, so we know about their efficiencies, and that efficiency can be calculated by using bomb calorimeter, and it can be expressed by octane numbers and cetane numbers also. So here, if you consider a petrol, so petrol which is used for the running of motor vehicles, so its octane number is around 60 to 70. This is the octane number of petrol. Octane number of petrol. So this petrol, when it is mixed with a small amount of additives, the petrol when it is mixed with small amount of additives like alcohol, okay, along with petrol, we call this combination as power alcohol. We call this combination as power alcohol. So once again I repeat, power alcohol is nothing but a petrol which is blended with alcohol, and this blending portion, that is the amount of alcohol which has been added to the petrol, it will be just 25% of alcohol, and remaining 75% will be petrol. Okay, so 25% alcohol will be added to 75% of petrol, and this constitutes overall 100%, and this fuel that is petrol which is mixed with power alcohol or ethyl alcohol, we call it as the blended petrol, or it is also called as power alcohol. Okay, so hopefully I am clear about this. So power alcohol, once again I repeat, power alcohol is also a fuel. We call it as a blended fuel which is used to run motor vehicles, where the alcohol is mixed with petrol, okay, in 25 and 75 portion to enhance the octane number of petrol. Since the petrol has the octane number around 60 to 70, and alcohol it is having an octane number up to 90, so its efficiency is more here. So when this alcohol is mixed with petrol, it leads to power alcohol, and this power alcohol, it is having greater efficiency compared to the normal petrol, and it can be used to run automobiles. So now we shall discuss about the synthesis of this power alcohol, how this power alcohol has been synthesized, and what are its advantages and disadvantages. Okay, so power alcohol, how it will be manufactured or synthesized. We are very familiar about the word fermentation, because this will be studied from pre-university classes, and fermentation is nothing but the process in which we are breaking down the larger sugar molecules into small molecules. Okay, larger sugar molecules are broken down into small molecules, and the process which has been used here, we call it as fermentation. So this fermentation process, it takes place in the presence of enzymes, suitable enzymes which has the ability to break that large sugar molecules into smaller molecules. Okay, so this fermentation process is the thing which we use to produce or to synthesize alcohol. So alcohols are obtained by fermentation process, and this fermentation process takes place at 30 degree centigrade. So how this alcohol will be generated here? See, the major raw material which is used for the generation or synthesis of this power alcohol is molasses. is molasses. So this word is very familiar for us. Molasses is nothing but a dark thick syrup which is obtained after crystallization of sugar from sugarcane juice. Okay, once again I repeat, molasses, it is a dark brown color thick syrup which is obtained after crystallization of sugar from sugarcane juice. Okay, so this molasses, it will be containing around 50 to 60% of sugar in it. It contains 50 to 60% of sugar in it. Okay, it is a very thick syrup. Okay, so and its viscosity is very high. So from this molasses, we are using this molasses as a raw material for the synthesis of alcohol. Okay, so alcohol means it is nothing but ethyl alcohol. Okay, so this molasses, it will be subjected for fermentation process. So molasses, it is nothing but a sucrose which contains sucrose in it. This is the large sugar molecule. This is what we call it as sucrose. So this sucrose will be subjected for fermentation process. It will be subjected for fermentation process in the presence of invertase as an enzyme. In the presence of invertase as an enzyme. Okay, and this invertase, it will be grown on yeast. Okay, so that will be reacted with sucrose or made to come in contact with sucrose, that is molasses. And in this first step, fermentation process takes place and sucrose will be converted to glucose and fructose, that is large molecule sugar will be converted into smaller molecule sugars. Okay, so it will be converted into C6H12O6 plus C6H12O6. And this process takes place in the presence of water. So when sucrose in the presence of water along with invertase enzyme, it undergo fermentation process and it gets converted into glucose and fructose. So here glucose and fructose are the two sugar molecules which are obtained when a large sucrose molecules will get fermented. So fermentation means, you came to know, it is nothing but breakdown of larger molecules of sugar into smaller molecules. So hence sucrose has been converted into glucose and fructose. Further, okay, we shall consider this glucose and fructose, two molecules of glucose, is further subjected to fermentation process in the presence of zymase as an enzyme in yeast. Okay, and this leads to formation of C2H5OH along with carbon dioxide as a gaseous molecule which is released here. So C2H5OH, this is nothing but ethyl alcohol. Okay, if you balance the equation, it becomes 2C2H5OH. Okay, C6H12OX in the presence of zymase as an enzyme in the yeast, it is getting fermented to ethyl alcohol along with carbon dioxide as a gaseous molecule which easily escapes to atmosphere. So now we have produced or synthesized ethyl alcohol from molasses. Okay, we have synthesized ethyl alcohol from molasses. So these are the two steps of reactions which takes place while synthesizing ethyl alcohol. Okay, that is from raw materials such as molasses to ethyl alcohol. The following reactions takes place. So you should be very familiar about this fermentation process because it takes place in the presence of enzymes like invertase and zymase. And this reaction is carried out at 30 degrees centigrade. Okay, and at that particular temperature, okay, and the required time, so we convert sucrose into ethyl alcohol. So this produced ethyl alcohol, okay, it contains around 15% of sugar in it. Okay, and further it has to be subjected for distillation process. It has to be subjected for distillation process, because whatever the ethyl alcohol we obtain, that has been obtained here, okay, so that will be just around 75 to 80% pure. 75 to 80% purity will be there in that ethyl alcohol, and this ethyl alcohol has to be further purified, because we need absolute alcohol to blend with petrol. Okay, so further ethyl alcohol will be purified, okay, and our last obtained product, okay, we call it as absolute alcohol. We call it as absolute alcohol. So absolute alcohol will be 90 to 95% pure. 90 to 95% purity will be there in this absolute alcohol, and this alcohol is used to blend with petrol. It is used to blend with petrol. Okay, so this is about the synthesis process. If this is clear, I would like to go for the next topic, that is about the advantages and disadvantages of power alcohol. What are the advantages and what are the disadvantages of power alcohol? Okay, so advantages, the very first important thing is to know about advantages of power alcohol. As I told, petrol, its octane number is around 60 to 70, that's all. So its efficiency is very less compared to ethyl alcohol, because ethyl alcohol's octane number is varying from 85 to 90. So when this ethyl alcohol is blended or mixed with petrol, so the product what we obtained is called as power alcohol, and gradually when ethyl alcohol is mixed with petrol, its octane number will also increase. So higher the octane number, greater will be the efficiency of the fuel. So hence this power alcohol, it gradually increases gradually increases the octane number of the fuel. So if octane number of the fuel increases, means its efficiency also gradually increases. Efficiency also increases. So as the efficiency increases, what happens? Definitely the motor vehicles will give more mileage. That is one of the advantage of this power alcohol. Okay, and we can also reduce the usage of direct petrol. Okay, because we know that non-renewable energy sources, after certain period of time, okay, so they may get exhausted. So just to avoid that, this petrol can be blended with this power alcohol, and we are increasing the volume of fuel, and at the same time we are also increasing the octane number of the fuel with greater efficiencies. Okay, so these are some of the advantages here. Coming to disadvantage, what will be the disadvantage of this power alcohol? See, obviously power alcohol, it will be having its own disadvantage, especially the power alcohol, that is the blended petrol with alcohol, when it is present in petrol tank, and that particular vehicle is being placed in a very cool temperature. For example, the Himalayan ranges, where the temperature will be around -7 degrees centigrade. At this particular temperature, what happens? The petrol and alcohol will get completely separated. Okay, it will get completely separated. Since its density is very low, what happens? The alcohol and petrol will be separated in a petrol tank, and the layers which has been formed here, okay, that will never allow the alcohol to mix with petrol. So when this separation takes place, then it will be very difficult to start the engines. So that is one of its disadvantage of power alcohol. Okay, at a very low temperature, okay, the power alcohol, that is the ethyl alcohol, will never mix completely with petrol, and it gets separated due to low temperature, and ignition will be very difficult. So we can't start the engines smoothly. Okay, so we need to wait till the temperature rises, and then this particular alcohol should get completely mixed with petrol, then only we can start engine very smoothly. Okay, that is one of its disadvantage here. Okay, so this is about the clear it's about the power alcohol, how it has been synthesized, and what are its advantages and what are its disadvantages. Okay, if this is clear, next we need to go for the next topic, that is synthesis of biodiesels. Okay. What do you mean by these biofuels? So the name itself indicating bio means natural. So fuels, we know those are nothing but the chemical substance which produces large amount of heat when it is being burned in the presence of an oxidant. So any particular fuels which are obtained by degradation of biological matters, it might be a dead and decayed parts of plants or animals or algae. Okay, so with a certain period of time, okay, whatever the obtained product which comes under this decomposition process, okay, we call that as biofuels. Okay, under this biofuels, today we shall discuss about biodiesel. We shall discuss about biodiesel. So how we synthesize this biodiesel, synthesis process. Next we need to discuss about its advantages and disadvantages. We know each and everything, it has its own advantages and it will be having its own demerits also. So here biodiesel, the name itself indicating, we are producing the diesel by using natural products. So these biodiesels are mainly obtained by vegetable oils. Okay, like soya beans, soya seeds. Okay, and biodiesels have been also synthesized by using jatropha seeds. Okay, so these are some of the examples where we are using these raw materials for the synthesis of this biodiesel. Sometimes not only vegetable oils, we are also using some animal fats, or we call it as animal oils also, for the production of this biodiesel. Okay, so biodiesel are obtained by such raw materials. And what are the process we are using for the synthesis of this biodiesel? See, for the synthesis of biodiesel, we are very familiar about the process, what we call it as trans-esterification. Trans-esterification. What do you mean by this word trans-esterification? So this you people have learned from your pre-university classes, esterification and trans-esterification. So trans-esterification is nothing but conversion of alkoxy groups of ester with alcohols, or we are just replacing the alkoxy groups which are present in long chain fatty acids or lipids. Okay, that will be completely replaced, that is alkoxy groups esters will be replaced by alcohols. It will be replaced by alcohols. So this replacement of esters by alcohols is termed as trans-esterification. It is termed as trans-esterification. Okay, so how this trans-esterification takes place? So let us discuss about the synthesis of this biodiesel by considering a best example of a triglyceride. Best example of a triglyceride. Okay, so synthesis of biodiesel from triglycerides. Okay, so triglycerides, the structure will be as such: CH2O, C double bond R. R refers to alkoxy groups. Okay, CHO, C double bond R, CH2O, C double bond R. So this is the best example for triglycerides. Triglycerides. Okay, so this triglyceride is treated with methyl alcohol, CH3OH, methyl alcohol. And we know that trans-esterification process, it mainly takes place in the presence of acid or a mild base. So here we are considering NaOH, sodium hydroxide, okay, which behaves as a catalyst, in this particular trans-esterification. So this reaction takes place in alkaline media because we are using NaOH as a catalyst, which initiates the trans-esterification process. So the triglycerides, when it reacts with methyl alcohol, okay, so what happens here? The presence of this alkoxy ester groups, okay, so these ester groups will be completely replaced by alcohols. It will be completely replaced by alcohols. So the final product which we can expect here is CH3O C double bond O R, okay, it gets combined with methyl group, CH3 group, okay, along with formation of CH2OH, CHOH and CH2OH, which is nothing but glycerol. We call it as glycerol, and this is known as what is the aim of this particular synthesis process? The product which is obtained, it is known as biodiesel. We call it as biodiesel. So here the triglycerides CH2 C double bond O R, CHCOOR, CH2 C double bond OR, the triglyceride in the presence of methyl alcohol, add sodium hydroxide as a catalyst in alkaline media, it leads to formation of a biodiesel along with glycerol formation. Okay, so here we can see, okay, overall the esters groups, it is completely replaced by alcohol groups. Okay, it has been completely replaced by alcohol groups. So this replacement of what? The alkoxy esters groups by alcohol, that is CH3OH, which is present in methyl alcohol. This process we call it as trans-esterification. We call it as trans-esterification. Okay, so due to the trans-esterification process, biodiesel will be synthesized. So this is a very simple step which is being discussed in the synthesis of biodiesel from vegetable oil or plant or animal oils. Okay, so if it is clear, next we need to discuss about the advantages of biodiesel. What are the advantages of biodiesel? Biodiesel, the name itself telling us, okay, it is a renewable source of energy. It is a renewable source of energy, okay, because we can synthesize biodiesel continuously by using vegetable oils or animal oils. Okay, so compared to normal diesel, this biodiesel, it is having higher octane number, cetane number, higher cetane number, because octane number is only for petrol and cetane number is for diesel. So biodiesel, it is having higher cetane number here. So cetane number is more compared to normal diesel means excuse, definitely biodiesel efficiency will be more. What are the next advantages here? It is a renewable source of energy where it can be replaced normal diesel with this biodiesel. It's the higher cetane number, efficiency of the engine gradually enhances. And the next advantage is it is highly eco-friendly. Means pollution free. Because biodiesel, it is completely 100% free from sulfur. It is complete 100% free from sulfur. Okay, when sulfur dioxide and sulfur trioxide are not released as a combustible product from the fuel, then there is no question of pollution. Okay, hence the usage of biodiesel greatly reduces the atmospheric pollution, that is environmental pollution, by release of these sulfurs, because biodiesel, it doesn't contain a single percent of sulfur in it, and hence it is highly eco-friendly, means pollution free. So these are some of the advantages of biofuels, that is biodiesel. Apart from that, biodiesel, it is also having its own demerits, that is nothing but disadvantages of biodiesel. See, the very first thing here is biodiesel, okay, when the temperature is very less, when temperature is very less, means up to 15 degrees centigrade to minus 10 degrees centigrade. Okay, if the temperature is up to 15 degrees centigrade to minus 10 degrees centigrade. Okay, so what happens at this particular temperature? The temperature is very low, means this biodiesel, it starts getting solidified. Means it slowly starts converting from liquid state to solid state. So at that particular point, we cannot start the engines. Okay, so it will be very difficult, and we need to wait to raise the temperature. When temperature gradually increases, what happens? This biodiesel will get liquefied from solid state, it will come back to liquid state, and then we can start the engines smoothly. Okay, so that is one of the demerit of this biodiesel. Okay, the next demerit, that is disadvantage of this biodiesel, is because for the synthesis of biodiesel, we are making use of vegetables oils and animal oil or fats as a major source. So now, if we are using this vegetable oils or the raw materials, that is vegetables as a raw material for the synthesis of this biodiesel, then it will be a great competition for food. Okay, so whatever the amount of vegetable seeds or oils which has been produced in the country, so most of that percent of vegetable seed or oil should be used for the synthesis of biodiesel. So hence it may lead to scarcity of vegetables, and a food competition can be created. Okay, so that is one of the major demerit of biodiesel. Okay, so hopefully I am clear about this. Biodiesel, okay, it is nothing but biofuel which is obtained by the transesterification of vegetables oils or animal oil, and I have already shown a simple reaction which takes place between the triglycerides and methyl alcohol in the presence of NaOH, which leads to formation of biodiesel and glycerol. Okay, so it is having its own advantages and disadvantages. So I am very clear about what are the advantages and what are the demerits, that is the disadvantages of biodiesel. Okay.